The machine was built for 2 years of work on an alien world. It has now survived for 14. Somewhere in that extra decade, 12 years of grinding exploration that NASA never planned for, the Curiosity rover stumbled onto something extraordinary. 21 organic molecules hidden in Martian rock. A potential biosignature. Evidence that on Earth exists almost exclusively alongside life. And the mission designed to confirm whether this actually is life. Cancelled 3 months ago. What does it actually mean to find organic molecules on Mars? Scientists have wrestled with this question for decades, and it is a frustrating puzzle. The word organic doesn't mean life. Not necessarily. It means carbon-containing compounds, the molecular building blocks that biology uses, but that chemistry can assemble without any living help whatsoever. We've found organics on Mars before. In trace amounts. Scattered hints. But 21 distinct molecules in one location, with mineral signatures that scream biology on Earth. That's not a hint. That's a shout. Let's be precise about what Curiosity's aging instruments actually detected. 21 distinct organic molecules extracted from Martian rock samples, the largest and most diverse collection of organic compounds ever found on the Red Planet. This isn't one ambiguous chemical trace open to interpretation. It's a molecular inventory, a chemical fingerprint. NASA's own press release describes the find as including mineral and organic signatures that on Earth are associated almost exclusively with biological activity. Almost exclusively. On our planet, these signatures mean life. The question that haunts every scientist working on this data is whether Mars follows the same chemical rules. In September 2025, 8 months before the public announcement, astrophysicist Neil deGrasse Tyson and astrobiologist David Grinspoon sat down to discuss what NASA had found. The scientific community already knew. They were already debating. What they were discussing was a word NASA chose very carefully. Biosignature. Not possible life. Not alien organisms. A potential biosignature. A chemical pattern that, in every environment we've ever studied on Earth, is produced by living things. NASA knew exactly what they had. They also knew exactly how dangerous it would be to say it too loudly. This is where the story takes a bitter turn. In January 2026, NASA effectively cancelled its flagship Mars sample return program. The mission designed to collect 43 pencil-sized titanium tubes of Martian rock and fly them to Earth for the kind of definitive laboratory analysis that could settle this question. Those tubes are already sitting on Mars right now. Collected by Perseverance. Waiting for a ride home that may never come. SpaceX announced further delays to its Mars timeline in February. And Curiosity's aging onboard laboratory, a robot's toolkit, really, is now the most advanced instrument we have for answering humanity's oldest question. We may be holding evidence of extraterrestrial biology, with no way to prove it. There's one more detail. Curiosity didn't just find organic molecules. It unearthed pure sulfur crystals on Mars, an element never before found in its pure form on the Martian surface. Never. In decades of exploration by multiple rovers and landers, pure sulfur remained unseen until now. On Earth, certain sulfur compounds are strongly associated with biological activity. Extremophile bacteria, organisms that thrive in conditions that would kill most life, produce sulfur signatures remarkably similar to what Curiosity detected. The combination of diverse organics, potential biosignatures, and pure sulfur creates a chemical profile that demands explanation. Abiotic chemistry can produce many things, but producing all of this together, that would require geological coincidence on a scale that strains credibility. Step back from the chemistry for a moment and consider what this actually means. If Mars harbored life, even microbial life billions of years ago, it would be the first confirmed extraterrestrial biology in human history. The first. Everything changes. The question of whether life is rare or common, whether biology is a freak accident or an inevitable consequence of chemistry, shifts from philosophy to data. And then there's panspermia, the hypothesis that life could travel between planets on meteorites, carried like seeds in the void. If Mars had life, it's possible that Mars seeded Earth, or Earth seeded Mars. We might not be looking at alien life. We might be looking at cousins. When Neil deGrasse Tyson and David Grinspoon, two scientists who have spent careers communicating the search for life beyond Earth, publicly broke down NASA's discovery, the tone was unmistakable. This wasn't hype. This wasn't speculation. This was measured excitement from people who understand exactly how extraordinary these findings are, and exactly how careful we need to be. NASA's language has been deliberately cautious. Potential biosignature, not proof of life, not aliens found, because the history of Mars life claims is a graveyard of overreach. The 1996 Allen Hills meteorite, the 1976 Viking results, each one generating headlines, each one ultimately falling short of proof. NASA remembers. That institutional memory is the reason they announced this discovery months after finding it, taking time to verify, to double-check, to ensure they weren't making the same mistake again. Fairness requires acknowledging the strongest counterargument. Organic molecules can form without life. The Miller-Urey experiment demonstrated this in 1953. Zap the right mixture of gases with electricity, and amino acids assemble themselves from non-living chemistry. Fischer-Tropsch synthesis can produce organic compounds through purely geological processes. Mars has known abiotic organic chemistry from meteorite infall and volcanic activity. Skeptics point out that 21 organic molecules, while impressive, could theoretically be the product of millions of years of non-biological reactions concentrated in one location. The mineral signatures that suggest biology on Earth might have different origins on a planet with different chemistry, different history, different rules. This is why the word potential carries so much weight. Potential is not proof, but it is enough to change everything. A rover designed for 2 years has spent 14 on an alien world, and it may have found the answer to humanity's oldest question. Or it may have found another tantalizing hint that leads nowhere. We don't know. We can't know, not with the tools we have. Not yet. The Mars sample return mission that could settle this lie's cancelled. 43 titanium tubes of Martian history sit gathering dust on a planet we can't reach. But the data exists. The signatures are real. And somewhere in the rock of a world 300 million kilometers away, there is either the chemistry of life or the most elaborate coincidence in the history of science. Either answer changes everything.